Okay, so here we go. So I want to find g of 3. So that gives me 4 times 3 minus 4, which equals 12 minus 4, or 8. And then I want to find f of 8, which is going to be negative 2 times 8 squared plus 1 plus 8, or negative 2 times 64 plus 9. That's negative 128 plus 9, which would be negative 119, negative 119. Second one, I'm going to find g of 4 first. So that's 4 plus 2, or 6. And then h of 6 is negative 2 times 6 plus 1. Negative 12 plus 1 is negative 11. Okay, and then the 3, let's see, h of negative 4x is going to be 3 times negative 4x, which is negative 12x. And then I'm going to find g of negative 12x, which is going to be 2 times negative 12x plus 2. So that's negative 24x plus 2. Okay, and then the last one is the hardest one. So I want to find, let me see if I can give myself a little bit more room here. G of x minus 1 is going to be negative 2 times x minus 1 plus 2, which is going to be negative 2x plus 2 plus 2, or negative 2x plus 4. I'm just going to write it up there. So then I'm going to do f of negative 2x plus 4, which is going to be negative 2x plus 4 squared, and minus 4 times negative 2x plus 4. And then, let's see. And then we get negative 2x plus 4 times negative 2x plus 4. Let's see, that's plus 8x and minus 16. And then if I distribute, I'm going to get, let's see, what am I going to get? 4x squared minus 8x minus 8x plus 16 plus 8x minus 16. So if I combine all my like terms together, we should get 4x squared minus 8x. Okay. Any questions? Okay, awesome. So we're going to go on. Today we're going to talk about inverse functions. And you learned this. Again, this is something you should have learned last year. So, yeah. No question? Okay, so oh my gosh, you guys. Okay, so our first definition is we're going to talk about what it means. We know what it means to be a function. we're going to define what it means to be a one-to-one function. So in order for it to be a function, we know that for every x, there's exactly one y. Great. That means for every input, there's only one output. If it has passed the vertical line test, there's just several different things we know about functions. But in order for it to be a one-to-one function, it has to be a function, which means for every x, there's exactly one y. And the reverse is true also. For every y, there's exactly one x. So not only does it have to pass a vertical line test, it has to pass a horizontal line test to be one-to-one. And the x's and y's can only go to one each. It can only have one each. So there's a couple little examples here in a mapping diagram. These are all functions. It's just showing the difference between a regular function and a one-to-one function. So A is one-to-one because I can take my arrows and it's going backwards also. So for every x, there's one y, and for every y, there's one x. So that means it's a one-to-one function. On the second one, this y goes to two x's, so it's a function, but it's not a one-to-one function. And then on the graph, I can do a horizontal line on this one, and no matter where I put it, it only touches one part. Where if I do a parabola on a it's a function, because if I do a vertical line test, it passes, but if I do a horizontal line test, it touches in two places, so therefore it's not a one-to-one function, it's just a regular function. And why do we need to know if it's a one-to-one function? When we're dealing with inverses, only one-to-one functions have an inverse. So that's why I can find inverses for anything, but for the inverse to be a function, the function has to be a one-to-one function. So I can find an inverse for a quadratic, but it might not be a one-to-one function. The inverse might not be a function. So that's what it's talking about, why we want to know if it's a one-to-one function. We are still going to find the inverses of them algebraically, but if we were graphing them, we couldn't say that the inverse is a function, okay? So that's notice I said if we are graphing them, we're not graphing right now. So inverse function is denoted by f to the exponent of -1 of x. It says f inverse of x. And how do I find an inverse? Algebraically, but let me finish my thought. Algebraically, it's super easy. I take my x and my y and I switch them, and then I solve for x. If I have like a table, all I'm going to do is take my x and y values and switch them. Mapping diagram, same thing. Graph, I take my points, I find my points, my x, y values, and I switch the x, y, and graph the new one. Okay. Right now in this particular lesson, all we're doing is finding it algebraically. So all I'm going to do is going to take my x and my y, put the x where the y is, put the y where the x is, and then solve for y to get it back to the y equals equation. Okay, so here we go. We're going to actually do it. I'll just show you how to do it. Find the inverse. So notice there's no y here. None of these four equations that I have showing have a y. Can anyone tell me where my y is in these equations?
Aren't they just the f of x and then the g of x?
Yeah, good. So the f of x and g of x is another way of saying y. So I can rewrite this. I can rewrite this as y equals 2x minus 3. And then what it tells me to do, it tells me to exchange my x and my y. So I'm going to exchange it. So wherever there's an x, I'm going to write the y. And wherever there's a y, I'm going to write the x. So this becomes x equals 2y minus 3. Okay, so is everyone okay with that? I really need to take roll because I forgot who I've let in. Toa, his ear here. I think I let Laura in. Ethan's here. And I think I let somebody else in. I'll have to look. Okay. So now I'm just going to solve for y. Just like we're going to do, just like you know how to do algebraically, we're just going to do it. So I'm going to add 3 to both sides. So I get x plus 3 equals 2y. Divide by 2. And I get y, but I want to show that this is an inverse, so I'm going to go back to, it was f. Ooh. So instead of writing y, I'm going to write f inverse of x equals x plus 3 divided by 2. Okay? So because I'm not going to graph this, I don't have to put it into, I don't have to do the x divided by 2 plus 3 halves. I don't have to divide it into the separate fractions. You can if you want to, but you don't have to. I can just leave it just like this. If I'm putting it into the chat box, make sure that you are putting, I would enter it this way, x plus 3 divided by 2. Because if you just do x plus 3 divided by 2, that only makes it look like the only thing being divided by 2 is the 3. Does that make sense? So make sure if we're doing it in the chat box, we're putting everything that's in the numerator in parentheses and then divide. And if there's more than one thing in the denominator, I'd put that in parentheses also. But right now it's only a 2. So I would just write it, I would type it into the chat box like that. Okay? So, okay, let's go ahead and do the number 2. Again, I'm going to do exactly the same thing. I'm going to exchange my x. Well, I'm going to rewrite it with y first. So I've got y equals x cubed plus 2. Exchange my x and y. So this becomes x equals y cubed plus 2. And now I'm going to solve for y. So subtract 2. And I get x minus 2 equals y cubed. Now, how do I get y cubed to become just y?
Divided by its cubed root or something like that.
I'm not going to divide it by its cubed root, but I am going to do a cubed root. I think that's what you meant, right?
Cubed root, so yeah.
So I'm going to take the cubed root of it. And if I take the cubed root on one side, I have to do it on the other side. And so, again, now I've got a y by itself, so I can rewrite this as the inverse. So this is not a f function, this is a g function. Okay. G inverse of x is going to equal the cubed root of x minus 2. And then in the, oh, good. And then in the chat box, because you can't do a cubed root, I would just do CBRT and then in parentheses x minus 2. Because you want to know everything that's underneath that cubed root, okay? Or you could actually spell out cube root if you want to. I just kind of abbreviated it like square root. Would it be SQRT, cube root, fourth root? Probably just do a 4 root. So, but that's how you would put it in the chat box, okay? So, let me slide this up. And now we're going to do some with some fractions in it, because we all know how you guys love fractions. But I'm going to do exactly the same thing. Okay, so I'm going to rewrite it as with a y. So I've got y equals 1/2 x plus 1. Switch my x and my y. So I've got x equals 1/2 y plus 1. Okay? Is there any questions so far? Are we doing okay? Okay. So get the y by itself, right? So I'm going to subtract 1. So I get x minus 1 equals 1/2 y. Okay, so how do I now I have to get rid of the fraction. How do I undo a fraction? Divide it, not divide, multiply by its reciprocal. So the reciprocal, I'm going to multiply by the reciprocal. Okay, so if I multiply by the reciprocal, it's just 2 over 1, which in that case is just 2. Those go away, and I get left with y. Or in this case, f inverse of x. And 2x minus 2. Yeah, okay. Multiply the denominator, divide by its, good job, you guys. Okay, so the last one, same similar thing, right? I'm gonna rewrite y equals 2x plus 1 divided by 3. Rewrite. Exchange my x and my y. So x equals 2y plus 1 divided by 3. So now I have a fraction to start with, and Jalen actually already wrote the answer in here. I'm going to multiply by my denominator to get rid of the fraction. So I'm going to multiply by 3 and multiply by 3. So I get 3x equals 2y plus 1. And then I just 3x minus 1 equals 2y. Divide by 2. So I get, it's an f function, f inverse of x is going to equal 3x minus 1 divided by 2. Okay. All right, now you guys are going to try. So we've got these 2 problems here. I'll try and leave this up here, especially the second one. So here we go. Exchange the x and the y. So I've got y equals 3x minus 1. Exchange them. So I've got x equals 3y minus 1. Add 1 to both sides. So I've got 3y equals x plus 1. Divide by 3. F inverse of x is going to equal x plus 1 divided by 3. And if I was putting that into the chat box, just like kind of like before, I would go x plus 1 divided by 3 in parentheses. Okay, and then the number b here, y equals x minus 2 cubed. And if I switch them, I've got x equals y minus 2 cubed. So this time I have to take care of the cube first. So I'm going to cubed root it. Okay, and then that means I've got y minus 2 equals the cubed root of x, and then I'm adding 2 to it. So this would be f inverse, should be a parenthesis, of x is going to equal the cubed root of x plus 2. Notice the 2's not underneath the cubed root, okay? Or you could write it, you could put the 2 in front, 2 plus the cubed root of x, and then there's no way that you'd ever get confused that the 2's underneath the cubed root or not. I don't care which way you do it. And how I would type that into the chat box, if I was going to do it, I would just do 2 plus CBRT cubed root x. Okay, so you don't have to try and do the, anything where just if you do CBRT, that means cubed root for me. And so I know that's a cubed root. And then just the x, because that's the only thing inside the cubed root. If there was more, if it was like the x plus 2, then I'd put that in parentheses. Whatever's with the cubed root, I just would put in parentheses. Or yeah, you could, someone did this and just put the x in parentheses next to the cubed root, so you know that's what's in there. So that's how I would type that in there. I hope that makes kind of makes sense when you're dealing with a root. Okay, so I think you got 2 more problems to do. With the next page, yep, there we go. So there's 2 more problems right there. So I'll give you okay, let's see. So we've got, what do we have? Y equals the square root of 2x plus 3. Switch them, so I've got x equals the square root of 2y plus 3. Well, how do you undo a square root? Well, I'm going to square it. If I square one side, I've got to square the other side. So I've got x squared equals 2y plus 3. Subtract 3. X squared minus 3 equals 2y. Divide by 2. So f inverse of x is going to equal x squared minus 3 divided by 2. And if I was putting that into the chat box, it would be x caret key squared minus 3, in parentheses, and then divide by 2. Okay. Okay, next one. So y equals 3x plus 2 divided by 5. Switch my x and my y. So x equals 3y plus 2 divided by 5. Take care of the fraction, multiply by the denominator. So I've got 5x equals 3y plus 2. Subtract 2. 5x minus 2 equals 3y. Divide by 3. So f inverse, it is f, okay, of x equals 5x minus 2 divided by 3. Okay. Okay, so there we go. That's just how to find an inverse algebraically, not too bad. So now we're going to talk about the composition of inverses. And this is basically how if I'm given 2 functions, how I tell if they're inverses or not. So if you're given they'll say, there'll be one of 2 questions. They'll either give you 2 functions and say, are these 2 functions inverses? And then you'll do this one of these to tell if they're inverses. Or they'll say these 2 functions are, or they'll say verify that these 2 are inverses of each other. And so if I'm verifying inverses, I would do the same thing as if I'm showing if they're inverses. It's pretty much the same question. Except in one they'll call them f and f inverse, and the other they might call them f and g. They'll call the functions different names. So here's what it says. It says I take the composition, right, which we did yesterday. I either take f inverse and put it inside of f. It's basically what it's saying. I take f inverse of x and slide it into f. And my answer should be x. That's what we're looking for. If I put a function inside of another function and my answer is x, then they're inverses of each other. If it all reduces down, everything goes away, and I'm only left with x, then they're inverses of each other. And it goes either way. If I put f inside of f inverse, which is what the second one says, and I simplify it all the way down, I should get x with if they're inverses. So that's a way to verify if they're inverses, or to show that the 2 are inverses. Whichever way they decide to word the question. I've seen them worded both ways. So we're going to do that, and I'm going to show you how it works. So it says, let f of x equals 2x plus 1 show that f inverse of x equals x minus 1 divided by 2. So I'm going to take, it doesn't really matter. I'll get the same result either. I should get the same result either way. So I'm going to take f inverse of x. So I'm going to put f inverse. I'm going to put the inverse inside of f. That's what I've decided to do. So I know that f inverse, just like yesterday, f inverse of x is x minus 1 divided by 2. And then I want to find f of x minus 1 divided by 2, right? So in f, wherever there's an x, I'm going to put x minus 1 divided by 2 plus 1. So these twos cancel out, or make a 1. I hate saying canceled out, sorry. They make a 1. 2 divided by 2 is 1. And then I get left with x minus 1 plus 1, which leaves me with x. And because it left me with x, it shows that they're inverses. Okay? Questions, anybody? We're going to do some more of this, so let's go. Let's go to the next page. I'm like looking at the bottom. So this says show that the following are inverses of each other. So we're going to do just what we did. And show that they're inverses of each other, okay? So the first one is called f and g. So it doesn't matter, just pick one, put them inside of the other. So we can do g of f of x. So that means I know that f of x equals 2x plus 6. And so I'm going to do g of 2x plus 6, which is going to equal 1/2 times x, which is now 2x plus 6, minus 3. And half of 2 is x, 1. Sorry, is x. Well, half of 2x is 1x. And half of 6 is 3. And then I've got minus 3. So that equals x. So they're inverses of each other. Okay, again, it doesn't matter. So on number 2, I think I'll go ahead and do f inverse of f of x. I'm just trying to do them both ways so you can see that I can either put f inside of f inverse or f inverse inside of f. It doesn't matter, and I can't remember what I did on the other one, so that's why I'm doing it this way. So f of x is the cubed root of x minus 4. And so then I want to find f inverse of the cubed root of x minus 4. So that's going to give me, let's see, what does that give me? That gives me the cubed root of x minus 4 cubed plus 4. Well, the cube and the cube root cancel. The cube cancels out the cube root. So I get x minus 4 plus 4, which equals x. So they're inverses of each other. Okay, so now you guys are going to try it. So I'm going to go ahead and, okay, here we go. So let's see, I think that I want to do f inverse of x. I think that one's the easiest to do. So this is 3x minus 2. And then I want to do f of 3x minus 2 is going to equal 3 over 3 over x minus 2 plus 2. Okay, so then I've got 3 over x, right? So basically, once I get to this spot, it's dividing fractions. And yeah, I know 3 is a whole number, not a fraction, but I can write it as a fraction. I can write 3 over 1 divided by 3 over x, right? I can turn any whole number into a fraction by putting 1 underneath it. So now I have two fractions that are divided. And how do I divide fractions? Well, I take the second one and I flip it, right? And then it becomes multiplication. So this becomes 3 over 1 times x over 3. So those 3's go away and I get left with x. Okay? So the 3's do cancel out, but you have to have a mathematical reason why they cancel out. And if you couldn't figure out that mathematical reason, you can't just cancel them out. And if you just cancel them out, then the x would be in the denominator. And if you left the x in the denominator, that is not equal to x. That's equal to 1 over x. So you have to figure out how to get it to the numerator. So that's why when you're dividing by fractions, that has to work out on that one. Okay? So on the second one, f inverse of f of x. Why not? So f of x equals x cubed minus 5. So I'm going to find f inverse of x cubed minus 5, which is going to equal the cubed root of x cubed minus 5 plus 5. Okay, which equals the cubed root of x cubed, or x. Done. Okay. That's it. Oh, and that's it. Oh, that's it. Wow. Okay, that is it. Okay. So you have